Yes, but three dimensions that introduction to three-dimensional geometry. Introduction to three-dimensional geometry we are starting. So in this, as we have done in class 10th, there were two-dimensional geometry. Now we are entering with the new topic. This is 3D. 3D is like in 2D we used to study X and Y axis. Now in 3D, we need to go for the Z axis also. So X and Y was there, now Z axis is also there. There were four quadrants, 1, 2, 3, 4. In 3D, it will be 8. So 5, 6, 7, and 8. These are the 8 octants. In the previous class, I have taught you about it, so you must be knowing, but it's for revision sake. Once more, we are doing that. So from class 10th itself, I am coming. In the first quadrant, we used to have plus plus, then minus plus, then negative and negative, and last positive negative. Again same, positive positive, negative positive, negative negative, positive negative. Now z-axis first four will be positive and last four will be negative. This means in the first octant all positive. In the first octant all are positive. If I'm talking about fifth, then it is positive, positive, negative. Likewise, you need to remember. They used to ask us the things like there is a coordinate 2, -3, 4. In which octant it lies? So it lies in the fourth octant. Same ways, one more example I'm taking 5, -2, -3. Now, in which octant it lies? Eighth. So I suppose it is really very easy to think about it. After this topic which now I am starting, this is from class 10th itself. On x-axis, y and z coordinates are 0. On x-axis, y and z coordinates are 0. Same ways, on y-axis, x and z coordinates are 0. On z-axis, x and y coordinates are 0. On x-axis, other two coordinates will be 0. On y-axis, rest of the two coordinates will be 0. On z-axis, x and y will be 0. Same ways, when we are talking about axis for plane, on x, y plane, z coordinate is 0. On x, y plane, z coordinate will be 0. On yz plane, x coordinate will be 0. And last, on xz plane, y coordinate will be 0. These are the basic things which we must remember. Once again, I must show you the coordinate pattern. Like, see, this was x-axis. This is y-axis. X and y-axis are perpendicular to each other. So x, y. This plane seems to be xy plane. Exactly, overall is xy plane, but I'm going for the z axis. That's why I said a specific reason. This is set as z axis. Keep in mind, in three-dimensional geometry, x, y, and z, x, y, and z axis are perpendicular to each other. X, y, and z axis are perpendicular to each other. So these three are perpendicular to each other. So we have got idea that each axis is perpendicular to each other. And now the region lying between the two axes is known as plane. Region lying between the two axes is known as plane. Like we are supposing our room, one of the corner we must take, and from that one of the line which is with the one wall and the roof, one line is going, that we can say x-axis. Between the two, let me show you, that will be better, na? X-axis, another line z is y-axis, and this will be down the z-axis. So the roof will be xy plane. Now this axis is x-axis, this is y. In three dimension, when we are thinking about the different planes and different lines, now we need to think how to calculate the distance between the 2 points, how to calculate the distance between the 2 points. So first I'm taking point, it is x1, y1, z1. Another point I'm taking x2, y2, z2. This is AB. We are calculating distance between AB. Distance between AB. So AB or D. From class 10th, we remember the distance between the 2 points was x2 minus x1 to whole square plus y2 minus y1 to whole square plus z2 minus z1 to whole square. Now, I suppose you remember in class 10th, we were learning till this only, because that time we were studying two-dimensional geometry. Now we are studying 3D. So in 3D, we need to reach till the Z coordinate. So Z also we need to add. So now the formula will be under root x2 minus x1 to whole square plus y2 minus y1 to whole square plus z2 minus z1 to whole square. So like this way, we could do the questions. One question I'm taking, a very simple question I'm trying to take. See this, I'm taking a 1, 2. Another point I'm taking 1, 4, 3. Now we need to find the distance between these 2 points. This I'm saying A, B. So distance between A, B will be under root x2 minus x1 to whole square, that is 1 minus 0 2 whole square plus 4 minus 1 2 whole square plus 3 minus 2 2 whole square under root 1 square plus 3 square plus 1 square under root 1 plus 9 plus 1 under root is 11 units. This is the distance between the given 2 points AB. This is the distance between the 2 given points AB. It is square root 11 units. So we have got idea. Now there could be, see, one question is given, question number 2. It is, there are 3 points given. We could say them A, B, C. A is having coordinates minus 2, 3, 5. B is having coordinates 1, 2, 3. And C is having coordinates 7, 0, minus 1. We need to show whether it is collinear or not. To show collinear, what we are supposed to do? A, B, plus BC. Best way is, after calculating the distances between AB, BC and AC, we need to see the sum of two small distances must be equal to the sum of big distance, because ABC lie on the same line or different, that I don't know. So I'm telling you, there could be some change also. It is happening in the rare cases, but we need to take care of this thing also. So I suppose you all will be able to take care of this thing. After collinear, one question comes. This is, find the equation of the set of points which are equidistant from. We need to find the equation of the set of points. Let that point is x, y, z. This is equidistant from this question number 4. 1, 2, 3. As well as it is equidistant from the point 3, 2, minus 1. This point I am saying P, this one A and P. It is said to us that AP is equals to BP. We need to find the equation of X, Y, Z. So PA is equals to PB. PA square equals to PB square. If the distance is equal, then its square will also be equal. PA equals to PB. This will help us to remove the square root. Now directly distance formula we are applying. X minus 1 2 whole square plus 5 minus 2 2 whole square plus z minus 3 2 whole square equals to x minus 3 2 whole square plus y minus 2 2 whole square plus z plus 1 2 whole square. Now it will become x square minus 2x plus 1 plus y square minus 4y plus 4 plus z square minus 6z plus 9 equals to x square minus 6x plus 9 plus y square minus 4y plus 4 plus z square plus 2z plus 1. Now see, some of the things are going to cancel. X square to x square, y square to y square, z square to z square. 1, 1, 4, 4, 9, 9. Now everything we need to take on the one side. Minus 6x and 2x will become 4x. 4y to 4y also gets cancelled. 6z and 2z will become 8z. This implies x equals to 2z is the relationship between the x, y, z, which is helping us to say that PA is equals to PB, PA is equals to PB, and P is having coordinates as X, Y, Z. This was, we have supposed it in our assumption. Unknown point was X, Y, Z. Now we need to go to the next topic. This is said as section formula. Next topic is section formula. I suppose you know it very well. What is section formula? Let us think. From class 10th itself, we remember A, B, a point P I am taking. A is with the coordinates x1, y1, z1, x2, y2, z2, x, y, z. These x, y, z we need to find. Section formula. M ratio n. So x equals to mx2 plus nx1 upon m plus n. Hope you remember, it was also in class 10th. Same for y, it was m y2 plus n y1 upon m plus n. Z equals to m z2 plus n z1 upon m plus n. So hope you are able to remember this. Only for Z we need to apply the same technique. Means the section formula is mx2 plus nx1 upon m plus n. For y it is my2 plus ny1 upon m plus n. Same for z will be mz2 plus nz1 upon m plus n. If we need to go for the midpoint, so midpoint formula will be we are calculating the midpoint between the x1, y1, z1 and x2, y2, z2. We are saying it will be x, y, z. So x will be x1 plus x2 by 2. Y will be y1 plus y2 by 2. Z will be equals to z1 plus z2 by 2. This is the midpoint between the given points x1, y1, z1 and x2, y2, z2. One more thing, this is new for us, section formula for external intersection. Yet we were doing intersection internally. Now we need to go for externally. A, B, point P is lying outside the line segment AB. Its coordinates we need to calculate. So this point is x1, y1, z1. This point is x2, y2, z2, and point P is having coordinates x, y, z. So we are going to calculate the coordinates of point P. So this line segment is divided into the ratio, again m ratio n, but now it is externally, whereas from class 10th we remember that was internally. Now we need to go for externally. So it will be m, this will be n. So the section formula will be x will be equals to mx2 minus nx1 upon m minus n. Only the difference which is coming is when we are talking about the distance from, sorry, section formula internally in between positive sign lies. For externally, in between, negative sign will be coming. Only this is the small difference between the internal and external intersection. For y, it will be my2 minus ny1 upon m minus n. For z, it will be mz2 minus n z1 upon m minus n. So this is the section formula for the external intersection. One last thing which is required for the introduction, then we need to go to the questions. It is centroid of a triangle. This is the triangle A, coordinates Z2, last is X3, Y3, Z3. So when we need to think about the centroid, we know what is centroid. Main point where the meeting. Main point where writing median in ratio 1. So and opposite into two, this divide opposite into two equal. So equation we class 10th also solving x2 1 x2 plus x by for y it will be 1 y plus 3 by same for question number 1. It is with the coordinates -2, 3, 5. Another one is 1 minus 4, 6. The line is divided into the ratio 2:3. Once it is internally, next time it will be going for externally. Once we need to go for internally, next time we need to go for externally. So I suppose internally you will be able to do. I'm going for the external intersection. So it will be 2:3. So x will be mx2 minus nx1 upon m minus n. For internal, it will be mx2 plus nx1 upon m plus n. For internally, plus sign will be coming. For externally, minus sign will be coming. So it will be m means 2, it is given. x2 means 1 minus n is 3 into minus 2 upon m minus n, that is 2 minus 3. So 2 plus 6 upon minus 1, it will be minus 8. X coordinate will be minus 8. Same we need to go for the y coordinate. Same we will be going for the z coordinate. So for the y coordinate now I am going. So y coordinate will be m, that is 2. It is given as 2:3. y2 means minus 4 minus n, that is 3, y1 that is 3 upon m minus n, that is 2 minus 3. So it will be minus 8 minus 9 upon minus 1, it will become 17. Same ways we need to go for z coordinate. Now here itself I am doing, because next sheet it will become tough. Z equals to mz2. M means 2, z2 means 6, minus n means 3, z1 means 5 upon m minus n is, sorry, 3. 12 minus 15 upon minus 1. So it will become 3. So the values of x, y, z are with us. These are minus 8, 17, 3. These are the values of the coordinates when external intersection is there. For internal intersection, this negative sign you need to put as positive, and you will be able to get the result. So I suppose you will be able to do this. Ayush Saxena. Ayush Saxena. Yes, as we have done the topic collinear, we have said that if collinear, we need to show that AB plus BC must be equals to AC. With the section formula also, we can go for the collinearity. If we are going for collinear in the section formula, then they must give the same ratio. Means whenever, like question number 4 is there, in this question number 4, when we need to show the given 3 points are collinear, points are 2, minus 3, 4. Another point is minus 1, 2, 1. And the last point is 0, 1 by 3, 2. These 3 points are collinear. In this case, what we used to do, this is second technique. Whatever you want to use, anyone you could use. So we are taking it k ratio 1. If it is giving us the same ratio for x, y, and z, that indicates that it is, yes, collinear. If the ratio is coming different, that will indicate us that it is not collinear. So let x2 plus n x1 upon m plus n. The value of x is -1 equals to m, that is k, x2 plus n x1 upon m plus n, that is k plus 1. So with cross multiply, minus k minus 1 equals to 2, minus k equals to 3, k equals to -3. Now with the value of k as -3 is saying us that it is external intersection. Minus symbol of k is telling us it is external intersection, but that is not a big deal. Now for y coordinate, when we need to go, at that time we must get the same ratio. So now that part I'm doing over here. Y is equals to my2. M means k is -3. Y2 is 1 by 3. N, that is 1, y1 is -3 upon m plus n means -3 plus 1. So this will become -1 -3 upon -2. That will become -4 upon -2, or it could be said as 2. This is coming same as 2. When we will be going for z, this you need to solve in the homework. That must also be giving us 1 as a value. With that we will be able to say that yes, the given points are collinear, as the ratio is coming same. With the same ratio we are calculating the other points that are also coming same. That indicates the 3 points lies on a line. So like this way we could solve the questions, and if you are able to solve these questions, you will be able to get results. So this was the introduction to the chapter. Now our task is to do this topic. Your doubts and problems we will see in the tomorrow's class. Piyush, you can stop recording.